Now that you've learned the basics of how to work proofs, I'd like to offer you some extra examples of that very thing. All the problems that I'm going to work in these proof examples in these different videos are from exercises 3.4, Roman numeral 6 in your textbook. So let's go to the first one. I wanted to show you all an example of a proof where you're going from a false premise to a true premise. So the first thing we would do with an argument like this is to read through it. We would say it is false that some Ficus benjaminus are untemperamental houseplants. Therefore, all Ficus benjaminus are temperamental houseplants. The next thing you would want to do is go through and find the standard form and also anywhere that you might see that there is a false. So we have it is false that some are, therefore all are. You want to look for term complements as well. So Ficus benjaminus and Ficus benjaminus are the same, but temperamental houseplants and untemperamental houseplants are term complements. The un will be the non, and you can use T to represent temperamental, and temperamental will be represented by T, as I said. So the standard form argument that you would begin with is, it is false that some F are non-T. You could use other letters if you wanted to. Therefore, and don't forget this line, it's very important. It means therefore. If you leave it out, there will be points taken off. Therefore, all Ficus benjaminus are temperamental houseplants. So here we're going from a false premise to a true conclusion. Remember that when you're dealing with proofs, you are only working with the premises. So it's okay if the eventual traditional square of opposition that you use does not match up with the truth value of your conclusion. The work that we're doing is only with the premise, and we're using the conclusion as a guide. So if we start our proof, it ends up being the first statement ends up being a restatement of the premise. I'm going to put given. You could also put assumed true. But let me remind you that when we say that this is assumed true, we mean the entire thing is assumed accurate. So if you have a false in front of it, that means it's assumed correct that it's false or true that it's false. So the true there in the assumed true isn't an actual truth value. It's just an indication that this should be assumed to be correct. So at this point, you would go to the square. And determine all the truth values that are necessary to work the rest of the proof. So you're starting off with a false I statement. So I will be false on the traditional square. By the contradictory relationship, E will be true. Truth can flow downward to O, making O true. And then the contradictory relationship between O and A makes A false. Okay, so now we have some decisions to make. The traditional square of opposition is the only place where you can move in between universal statements and particular statements. And it is also the only place that you can move between the truth values that you need. So we want to change the truth value from false to true, because eventually we want it to be true because that's what our conclusion looks like. So when we're using the square, we don't want to go anywhere that's false because we don't want to keep that particular statement false. We also don't want to use the O statement in this particular scenario because we want to use the one that's closest in the way that it looks, in this case, the other universal statement to the conclusion. So I'm going to change this statement. I'm going to drop the false because we're going somewhere that's true. I'm going to change this statement to an E statement. The terms are going to remain the same. And how did I get from here to here? That's what I want to put in this set of parentheses where this step is concerned. the relationship between I and E on the square is the contradictory relationship. So you can either write contradictory or contradiction. But it still doesn't look exactly like the conclusion, all F or T. It says no F or non-T. So we need to now, if we have used the traditional square of opposition appropriately to change truth values and to move between universals and particulars, now we can move on knowing that we don't need to go back to the square, and we can see how we can use conversion, obversion, and or contraposition to finish out the proof. So in this case, there's one thing that will change this no to all and this non-T to T, because remember, we're taking the premise and making it look like the conclusion. And that is obversion. So all are, right? It changes the no to all, obversion does, but then it also replaces the term, replaces the predicate term only with its term complement. So non-T becomes T, and it leaves the subject term F alone. How did I do that? I used obversion. So now I check again, does my conclusion here or my work here look like my conclusion in the argument? It does. Thus, I have proven that I can get from the premise that's here to the conclusion, because when you're working with a proof, it's useful to remember that you are dealing with an argument that has already been identified as deductive and valid.